Okay. What from the white packet do you want to go over? What things in there do you not know how to do? Bryson? Number 4? Okay. Oh yeah, 4 is kind of a tough one. Actually, you probably need more space for number 4. So what am I going to do with those parentheses? Let's start there. For example, this first parenthesis. I know that I need to square it, and I need to multiply it by 3. Which one of those things do I do first? Order of operations tells me I would square. How do I square parentheses? Someone with some confidence. Say it again. Double, like write it out twice. Yep. So I'm going to start by writing this as 3a plus b, a plus b, minus 4, a minus b, a minus b. Okay, so I wrote both of my parentheses out twice. Now I'm going to go ahead and FOIL here and FOIL here. Okay? So when I FOIL this, a times a is a squared. And look, I'm leaving the 3 out here and putting this all back in parentheses so I can distribute the 3 later. Then I would do a times b and write that as ab. Now my next one would be b times a. How would we write that? We could write it as BA. There's nothing wrong with writing it as BA, but isn't that really the same as this? AB. And if I write it as BA, I might not recognize that those are like terms and can be put together. So I always try to put my letters in order. So I would write this as AB again. And then at the end, B times B is B squared. Good there? Everyone okay with that FOIL process? And now I'm going to do the same thing on the other side. So I'm going to have minus 4 parentheses, and then a times a is a squared. A times negative b gives me a negative ab. Negative b times a. Again, I would write those letters in order. So I would say negative ab. And then what's negative b times negative b? Positive b squared, yep. Okay. At this point, if you wanted to combine your like terms, so you've got AB and AB and AB and AB, you could. You can't just start canceling things out because you've got a 3 and a 4 that are going to distribute. I think I'm going to go ahead and do the distributing first, and then I can just combine everything all in one step instead of combining a little bit now and then combining more later. So I'm going to distribute the 3 to all of these things, and I'll write that up here. So that's going to be 3a squared plus 3ab plus 3ab plus 3b squared. Nope. 3b squared. B squared. What am I going to distribute to the other parentheses? Negative 4. Remember that that's a negative. So all of these get multiplied by negative 4. So now I'm going to have minus 4a squared. This negative 4 and negative ab are going to give me a plus 4ab plus another 4ab for the second one here. And then this would become minus 4b squared. Okay. That was loads of fun. Now what can I do? Now I can just start combining, right? So like 3a squared and negative 4a squared go together. What does that make? Negative 1a squared, yep. And I like to cross them out once I've combined them. I have 3ab, 3ab, 4ab, and 4ab, which I believe makes 14. Does that make sense? Where I got that from? 3, 3, 4, 4. Okay, so that's 14ab And then 3b squared minus 4b squared would give me negative 1b squared. And this would come out to be my final answer. So this is kind of just checking to see if you know how to simplify. Okay. What else from anywhere in the packet? We're just going to do kind of a handful of these right now and then give you some work time. We'll do more of this on Monday. Megan? 7. Okay. Good question on number 7. So a bread recipe calls for a rectangular pan that's 9 by 13. So here's my rectangular pan. 9 by 13. Actually, I think I'm going to put the 13 up here. I want to make that same recipe, but I want to use a circular pan. Okay, and I'm going to assume that the pan is the same depth. So I need it to have the same amount of space, right? So I need the areas to be equal. Does that make sense? That the areas need to be equal? So I have a circular pan. I'm trying to find the radius of the circular pan. So I'm trying to find this. Okay? And I want their areas to be equal to each other. How do I get area of this one? Area of the rectangle. Yeah, 9 times 13. How do I get area of the circle? Remember? There you go. Pi times r squared. And I want these two things to be equal to each other. Can you help me with 9 times 13? Thank you. So I now know that 117 must equal pi r squared. Now I have an equation and now I can solve for r. If I need to get r by itself, what do you want to do? Not divide by r squared. You're on the right track though. I want to get r alone, so I want to move stuff away from r. What stuff is with r? Pi. Let's divide by pi. Now some people might be wanting to, well, let me do this next step first. Can someone help me with 117 divided by pi? It's going to be ugly.
37.2.
Thank you. And that now equals just r squared. Now, how do I get rid of a square? Square root. Normally when we do this, we would need to have like a plus and minus answer. Why do I not need to do that for this problem?
You can't have a negative side.
Right, this is a radius that I'm looking for, so that negative answer wouldn't make sense. Okay, so what is this, 6 point something? Okay, I'm just going to go to maybe 6.1. Actually, it says nearest inch, so I could just say about 6 inches. I have some people with a problem like this that want to do the square root right away. The problem with that is the pi is not being squared. The r is being squared, but not the pi. So I don't want to take a square root of the pi. I only want to take a square root of the r squared. So that means that before I can take a square root, I need to get rid of the pi. And that's why I divided by the pi first. Good? Does that make sense? Okay. If you wanted to check this, if you were unsure about this one, I would just really quick in your calculator do pi times 6 squared, and it should come out close to 117. It's not going to be exact because of the rounding that we did, but you can always check your answer by plugging it into this area formula and making sure it matches what this one was. Okay? Danielle? Pretty much the same thing, except you're not working with a circle. So in this one, you would have here's your 12 by 8 dog pen. And then you have a square, and we're going to call those side lengths like x and x. So the area here is going to be 96. That's 8 times 12. How would I get area of this square? Michael?
Do the 8 times 12 and then square root it.
Okay. You're right. That's going to be my process eventually for my answer. How would I get the area of this square, the way it's drawn? Okay, it'd be x times x. Here's why that works is what I'm getting at, Michael. So 8 times 12 is 96. X times x, how could I write that? X squared. And then to solve that, I would take a square root. So in this one, I don't have to worry about the pi. But otherwise, yes, it's exactly the same. Okay? It's going to come out to be like 9 point something. Okay? All right, what else do you want to see from this packet? 16. Okay, yep, there's a lot going on in 16. So this, if I went through and marked in here like which lesson we did each one of these steps in, like A, B, C, D, if I marked down which lesson we did each one, every single one of those came out of a different lesson. All right, so you're kind of jumping all over the chapter here. But that's good. That's the point at the end of the chapter of like pulling it all together. Okay? So what translation maps the original parabola to its new image? Remember to write a translation, we just do a T, and then we tell, like, on the coordinate plane, what would this mean I was doing? So 7 to the left would be what kind of 7? That'd be negative 7. And then 5 down would be negative 5. So my translation would be T, negative 7, negative 5. Okay, that's all you have to do for a translation is put a T and then tell me on a coordinate plane if you did that movement, what coordinate would that be, or what, like, how would you move along the coordinate plane? And remember, when you write that translation, what is this really giving you about the parabola?
The coordinates.
Of the
Vertex.
The vertex, yeah, this is your H and your K. So when I get down to part B and it says write the equation in vertex form, just to remind you, here's vertex form. Nope, that's not vertex form, just kidding. That was going to be standard form. This is vertex form. Y minus K equals A X minus H squared. Now I have my H and my K to plug in down here. So I'm going to say Y. Now what's going to happen if I do minus negative 5 plus 5? And do you see why I'm choosing the 5 and not the 7? Because I'm looking for K. In the equation, the letters are kind of backwards. Where do I get A from? Yeah, up here. It said my original parabola was y equals 2x squared. So the A value in this one was 2. So I'm going to keep my A value as 2. 2 and then x. I'm going to do x minus negative 7. So that's really x plus 7 squared. That's vertex form. I stop right there. Vertex form. Remember when we did that? Good with that?
Yeah.
Now it says rewrite this equation in standard form. How do I get from vertex form to standard form? Michael?
FOIL.
Okay, FOIL, really our general, we're simplifying, right? So FOIL is a piece of the simplifying, but I'm going to simplify this. So I'm going to say y plus 5 equals 2, and then x plus 7, x plus 7. All right, so I wrote that out twice. Okay. Anyone think they can walk me through FOIL here? Just between these two things? Michael, go ahead.
You multiply the x by the x to get x squared.
Okay.
Then you multiply the 7 by the x.
Okay.
And 7 by the x again to get 7x plus 7x.
Uh-huh.
And then you multiply the 7 times 7 together to get 49.
Good. Okay, so there's my FOIL. I'm going to go ahead and put these two things together. So that's now going to say y plus 5 equals 2 times x squared plus 14x plus 49. Now, I'm not done though. So I did FOIL, but I still have a couple of steps left to go. What do I need to do now?
Multiply, distribute the 2.
Okay, distribute the 2 inside the parentheses. So I get y plus 5 equals 2x squared plus 28x plus 98. And then one last little thing that still needs to be done.
Subtract the 5.
Good. We got to move the 5 out of the way. So I get y equals 2x squared plus 28x plus 93. And that is my standard form. Everyone okay with that process? Tedious, boring, not the most fun thing I've ever done, but not difficult, right? All right, D, find the zeros of the parabola. Zeros is another name for what? Roots. How do I find roots? Quadratic formula. Yep, quadratic formula. So after all that, now I'm going to do the quadratic formula. So, quadratic formula, remember, is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? Which equation do I look at to get these values? So I've got an equation here, I've got an equation up here.
The one in standard form.
Okay, so that's why I needed this in standard form, is because I needed to be able to find the zeros. Okay? Vertex form is good for finding the vertex. Standard form is good for finding the zeros. So that's why you have to be able to do both forms. So I'm going to look at this, and I'm going to plug in my values here. So I'm going to say x equals negative 28 plus or minus the square root of 28 squared minus 4 times my a is 2 times my c is 93 all over 2 times my a value, which is 2. Anyone struggling with plugging the numbers in there? Okay with that piece? Alright, I'm going to go in my calculator now, and I'm going to do just the square root piece. Squared times 2 times 93. What did we get?
No answer.
Unless I did something wrong. I got an answer. Square root of 28 squared minus 4 times 2 times 93 got like 6.3. Anybody else get that? Yeah? Okay.
No, I missed it.
Just making sure. Gosh, I'm going to run out of room here. So now I have negative 28 plus or minus 6.3 all over 4, because I'm going to just make that 2 times 2 of 4. Now where am I going to go with this?
Do the plus or minus.
Okay. Let's see. I think I'll just use up my margin of my paper here. So now I'm going to do negative 28 plus 6.3 over 4. And then I'm also going to do negative 28 minus 6.3 over 4. Now remember, if you do want to do those in your calculator all in one step, you will need parentheses around the top. Okay. So for this first one, negative 28 plus 6.3, I get like 21.7. I'm going to divide by 4, and I get negative 5.4. Does that look right for those of you who have done this? Okay. And then negative 28 minus 6.3. Enter, divided by 4, negative 44.1. Gosh, that seems really big. Oh, I did times, that's why. Whoops. That looks better. Negative 8.5, or negative 8.6, I guess. What does this tell you about the graph? What did I just find about this graph? the roots, which means, like on a picture, that would be what? Okay, it'd be the place where it crosses on the x-axis. So if I was going to graph this now, I've got a lot of information about this parabola here. If I was going to graph this, I would know the vertex would be at -7, -5, okay? And that when it comes up, and I know it's up because this is positive, it's going to come up and cross the axis at -8.6 here and -5.4 here. Okay, so that's what we know about this parabola. Is really that work got us these 3 points, which is enough to draw the rest of our parabola. Okay, if I was mean and asked you a 5th step to graph it, that's what I would do. Whew, that was a lot of me talking. Let's maybe hit one more right now, and then I want to give you some work time. One more from anywhere in the packet? No, we're all quadratics experts. Megan? Like 18, 19, 20? Anyone have a preference, one of the graph ones? 20? Okay. What I would do with these, quite honestly, and with anything that you have to graph, I would put them in your graphing calculator. Okay? And this one's nice because it's already solved for y, so I would go to y equals. I would do -2x squared plus 4x minus 1. Oops, delete everything else that's there. So there's my equation. Now, when I hit graph, and you might be in a different situation, but when I hit graph, look at my screen. Crisis, right? Everybody freak out. Okay. What's wrong? Why does my screen look like this? What's the last thing I did on my calculator, would you bet? Probably did Newton, right? When we were changing the window for Newton. I want to get back to a normal screen. So instead of freaking out, I'm going to hit zoom. And then option number 6, see it says zoom standard. That will always bring you back to a regular screen. So anytime I'm doing something up here and you're like, wait, my screen doesn't look like yours, you can hit zoom and number 6 and it will bring you back to this screen. Okay? So that gives me an idea of what my parabola looks like. Now, where do I go to get points so I can actually graph it?
Second graph.
Yeah, let's go to the table, which is above the graph key. And I would just look for any points on here that are small enough to fit on your graph. So like -1, -7, 4, 5, 6, 7 would go there. 0, -1, 1, 1, 2, -1, and 3, -7. Okay, and there's my parabola. So that's what I would do for any of these ones that require graphing. However, I don't think it would be a bad idea for even ones that don't require graphing. If you're looking for, say, the vertex or the roots or whatever, you can always throw it into your graphing calculator to verify. So, for example, in this last one that we did, this number 16 that took forever, I could put either form of my equation into the calculator. I'm going to put this one in just because this required some math to get there. So on a test, maybe you made a mistake and you wouldn't want to look at that one. But this one was just plugging numbers in. If I wanted to put this into a calculator, what would I have to do to it first?
Subtract.
I'd have to move the 5 over. I don't have to put it all the way into standard form. I don't have to do this. But I would have to put the 5 out here on the end and get rid of it here. So in my calculator, I'm going to clear that. I'm going to do 2 parentheses x plus 7 squared and then minus 5 on the end. And I'm going to graph it and look at it and make sure that all this other stuff seems to make sense. Okay? So I said that the vertex would be -7, -5. Does that look like that's in about the right spot? And then for my zeros, I got -5.4 and -8.6. Do those look like they're correct? Okay, so this would be a great way to check. Now, I don't know if you caught this. I glazed over it pretty quickly, but I almost made a mistake here. Okay, I had multiplied up here instead of subtracting. I just hit the wrong button. And I got some crazy answer like 44. Looking at that graph would tell me, hey, 44 is not correct. Okay? I mean, hopefully your brain would tell you 44 was not correct. But if it didn't, this would be a way to check too. Okay, so don't be afraid to use the graph in your calculator, even for non-graphing problems. Good there? Okay. Just glancing through the rest of your packet, what's got you the most intimidated? What are you the most scared of in here? Let me just help you out with look at the very back where it says solve. And this we wrote down right at the very end yesterday, but in case you were tuning me out by then. If you have a problem with just an x squared or a d squared or whatever letter you're using, if it just has an x squared, you're going to be able to get rid of that by doing a square root. You're going to be able to solve with a square root. If it's a problem that has an x squared and an x in it, and this might, I mean, these are going to have numbers in front of them and stuff, but if you have an x squared and an x, what do you have to use when it says solve? Quadratic formula. Okay? So just so you know when you get to this page. You don't have to do quadratic formula for everything. But. Okay. Let me